Hi guys. We're going to continue with two more examples of solving polynomial equations, getting all the possible answers, even if they're not real, and taking a look at what that means for our graphs. So here is example number 3 for today. Now, in this problem, I've already started factoring for you. So it's already been factored a little bit. We just need to check and see, like, can I factor it more? Now, it's important that this is set equal to 0. Because it's set equal to 0, I can just keep factoring. If it was set equal to something else, I would have to unfactor, move some stuff over, and then refactor into something different. All right, so here I have two binomials. I know that I should probably try to factor more because they both still have an x squared in them. If they were both just the letter x, I would be like, oh, already factored. I'm ready to write my answers. In this problem, it's a little bit trickier than the previous problems to figure out how many answers there are, because I can't just look at the biggest exponent. Each individual parentheses will give me its own set of answers. And so the first parentheses is going to give me 2 answers, and the second parentheses is also going to give me 2 answers. And so in total, I should get 4 answers. And if you actually multiplied this out into standard form, your biggest exponent would be x to the 4th. All right. Now, if we can factor these, that'd be fantastic, but we might not be able to. So we can factor the first one. The first one is called a difference of squares. It's called a difference of squares because I know the square root of x squared, I know the square root of 1, and it's being subtracted. And so I factored that into x plus 1 and x minus 1. Again, you want to look up your factoring from first semester to help you out. Now, the second parentheses is not a difference of squares because it does not have a subtraction sign. So I cannot factor that anymore. That means that my second parentheses is not going to give me nice, pretty answers. But I can get 2 very, very nice answers from those first now 2 parentheses. The first one is going to give me an answer of positive 1. The next one will give me an answer of negative 1. So I'm like done with those. Like those are 2 my answers, positive 1, negative 1. To solve the last parentheses, I do want to get the x by itself. So what I did was I took the plus 4 and I minused it to the other side. And then last semester we learned that in a problem like this, you can square root both sides to get rid of the x squared. Well, specifically the square on the x squared. Now, when you square root something, you have to put a plus or minus sign in front of it. That's what gets you your answers. And we're square rooting a negative. So this is going to get me 2 imaginary answers. The negative turned into the letter I, and then the square root of 4 is 2. And the plus or minus makes it 2 answers. So the 4 answers to my problem are positive or negative 1, that's 2 answers, and positive or negative 2i, that's also 2 answers. You could also write this out as 4 individual numbers. You could write 1, negative 1, 2i, negative 2i, okay? 4 answers. Just for reference, here's the graph for that problem. It was an index of 4 because we got 4 answers. So it starts high and it ends high. And it's crossing at the positive and negative 1, just like we would expect. All right, so this is what the problem ends up looking like. Remember that the 2 solutions that were imaginary are not going to show up on the graph. Here's our last example for today. In this problem, it's not factored, so not in standard form. But I can tell how many answers I will expect. I will expect to get 3 answers to this question. They might be real, they might be imaginary, there might be multiple of the same answer, right? We don't know that, but we know that there's 3 answers. Unlike with an x squared, I'm not going to do a cube root on both sides. I am going to move the 1 to the other side, and I am going to set it equal to 0, and I'm going to factor. Now, we did learn how to factor something like this in first semester. This is called a difference of cubes. And we learned a song first semester. So if you want to, you can always go back and rewatch that video. It is in the YouTube playlist. I believe we learned it sometime in November. It's Sum or Difference of Cubes is where you can find it. Okay. And when we learned this, it turned into 2 parentheses. The first parentheses was a binomial, and then the second one was a trinomial. So it was a little bit longer. And if you remember the song, it's you take the cube root of the first and the cube root of the last and the sign from the middle. Then square the first, change the sign, multiply together, and square the last. So this is what it looks like when you factored. Now, the one thing that kind of it's not good about the song is you're going to get a binomial that's fine, that's easy to solve for, right? It's x equals 1. But the trinomial, the second parentheses, that is never going to be factorable. And so that means that you're going to get those crazy answers, and you should use quadratic formula like we did in the first video. So again, first answer, super easy, x equals 1. That's one of my 3 answers. The other 2 answers are going to come from the trinomial parentheses, and we're going to do quadratic formula. Okay, so I'm going to go through that really quickly. Notice that I'm getting an imaginary answer. You know, that's how it wasn't factorable. Well, yeah, it's going to give us a weird answer. So these are my other 2 answers, one version with the plus sign, and then the second version with the minus sign. And so here are my 3 answers to this problem, the number 1, and then 2 imaginary answers. Here's what that looks like graphed. Now, this one had a different amount of answers than our other one we did in this video. So this one only had 3 answers. When there's 3 answers, it starts low and it rises up. Okay, so 4 answers, it's high and stays high. 3 answers, it starts low and then it goes up. And then it only has one real answer, which is the number 1, right? So that's here. That's where it's crossing right there. And then the other thing I want to point out is that your y-intercept, where it's crossing the y-axis right here, that is the same as your constant from the original problem. So in the original problem, it was x to the third minus 1. Minus 1 is going to be your y-intercept. So that's pretty cool. These are all little helpful hints to help you graph or to determine which graph is correct and which graph goes along with the problem. All right, guys, that's it for today. I will see you all tomorrow.